These are the section notes for 8.2, simplifying square roots of non-perfect squares. To simplify a non-perfect square, we're going to use this formula that the square root of AB can be broken up into two factors, the square root of A times the square root of B. Since nothing times itself can give me a 12, what we're going to do is we're going to list out the factors of 12 that we have. We have 1 and 12, 2 and 6, 3 and 4. Of these three factor pairs, we're interested in 3 and 4 because 4 is a perfect square. So what we're going to do is we're going to break up the 12 into the square root of 4 and the square root of 3. The square root of 4 is equal to 2. Square root of 3 remains as square root of 3. And that is how we simplify the square root of non-perfect squares. If we look at square root of 48, I wrote it down twice because there's two ways that you can attempt this problem. You can break up the square root of 48 into 4 and 12, or you can do square root of 16 and 3. One of these ways will result into the answer faster than the other, but both will give you the same answer. So for this one, you're going to end up with 2 root 12. However, root 12 can be still broken down as we saw here before. So this would be 2 times root 4 times root 3, 2 times 2 times root 3 is 4 root 3. So we got 4 root 3 there. And then if we take a look at this one, the square root of 16 is 4, and then the root 3 stays the same as 4 root 3. So when we broke it up into 16 and 3, we got the answer much quicker than what we did here with the 4 and 12, because 12 we could continue to break down into a perfect square factor. So when you break down a non-perfect square, the best possibility is to break it down so that one of the factors is the highest perfect square that you have. If you don't use the highest perfect square like we did here, then you have more work for yourself. So in the next example, square 50, this one doesn't have two options, but we're going to break this up into square root of 25 and square root of 2. And so this one is 5 root 2. And then square root of 45, we're going to break this up into 9 and 5, which is 3 root 5. You're going to see some examples that look like this where you need to simplify the fraction. What you simply do is you simplify the radical, square root of 9 is 3, and then use order of operations to finish up the problem. So we get 3. In the next part, we're going to take a look at the square root of variable exponents with variables. These are perfect squares right here. So the reason why x squared is a perfect square is because of x. So the square root of x squared is x. The square root of x to the 4th is x squared. And the square root of a to the 100th is a to the 50th. For the square root of perfect squares for exponents, what you essentially do is divide the exponent by 2. So 2 divided by 2 is 1. 4 divided by 2 is 2, and 100 divided by 2 is 50. When they're not perfect squares or odd exponents, what we need to do is we need to break it up, just like we did over here for the non-perfect square numbers. We're going to break it up into x squared and x, because x squared is a perfect square, and we have x root x. Because the square root of x squared is x, and the root x gets brought over. The trick here is when you have an odd exponent, to break it up into the two factors is to subtract 1 from it. If you don't subtract 1, you can get the same answer, just like over here, but it won't be using the highest perfect square available to us. So for x to the 5th, I'm going to break it up into x to the 4th and x to the 1st, and then my answer will be x squared root x. So for this example, you could have broken this up into x squared and x to the 3rd, but then x to the 3rd can continue to break down, so that's why I used 4 and 1. Again, we subtract 1 from the exponent to make the work a little easier. So in this example, we're going to subtract 1 from the 99, so I have x to the 98th and x to the 1st, and the square root of x to the 98th is x to the 49th root x. In our next set of problems, what I've done is I've combined the numbers and variables together in the radical. What we do is we treat them like they're separate problems. We're going to break each one up individually. 48, I'm going to break up into 16 and 3. And the square root of x squared, I'm actually going to leave alone because x squared is already a perfect square. Then I'm going to simplify the perfect square radicals first. The square root of 16 is 4. And the square root of x squared is x. And then I have root 3 attached. Since I can't simplify root 3, the final answer is 4x root 3. In my next example, the square root of 16 is going to remain the same because 16 is already a perfect square. X cubed is going to turn into x squared and x. Y to the 5th will be y to the 4th and y. I'm going to underline all my perfect square radicals and simplify them. The square root of 16 is 4. The square root of x squared is x. The square root of y to the 4th is y squared. And then I have xy that is left inside the radical. In my next example, I'm going to break 50 up into 25 and 2. And then keep y to the 12th because it's a perfect square. Simplify my perfect square radical, so this is 5, y to the 6th, root 2. In my last example, 69 doesn't have a perfect square factor, so I'm going to leave it at 69. The square root of x squared is a perfect square, so I'm going to leave that alone. Y to the 5th, I'm going to break down into y to the 4th and y to the 1st. Underline my perfect squares, so the square root of x squared is x, square root of y to the 4th is y squared. And then 69y stays inside the radical. In the next part, if you can reduce the fraction inside the radical, you're going to reduce then simplify the radical. So in this example, we're going to reduce the fraction first. The square root of 14 over 50 reduces to 7 over 25. And now I'm going to apply the quotient rule where I split up the radicals. Then I have square root of 7 over 5. In this example, I'm going to simplify. I'm going to reduce the fraction by 2. 36 divided by 2 is 16. 18 divided by 2 is 9. A cubed divided by a is a squared. So now I'm going to split up the radicals. The square root of 16a squared is 4a, and the square root of 9 is 3.